Good afternoon. We are going to do 6.2D and we're going to revolve. We're going to do volumes of revolution still, but now we're revolving around a non-axis line. So we haven't done this before. We've always either our axis of revolution was the X or Y axis. And now we're going to move that axis of revolution. Okay. So, good thing though, one thing to note, we revolve only about vertical and horizontal lines. So we don't have to worry about some sort of odd skew lines like y equals x or anything like that. Okay. And the kind of the big concept to remember here is anytime you need a distance, the distance between any 2 points is the distance between the top function and the bottom function. So remember, if you're looking for a distance between any 2 functions is the top minus the bottom. Top function minus the bottom function. So if we can figure that out, we can always get those R values for our washer, right? We can get the whole R and the big R and little r. If we're doing a y-axis rotation or a vertical line rotation, it's going to be the right function minus the left. Okay. And other than that, it's going to be kind of the same concept that we did yesterday. So our main total volume is equal to the integral from our bounds, right? Pi big R squared minus little r squared. And either dx or dy, depending on if it's a horizontal slice, it'll be dy. Vertical slice, it'll be dx. Okay, so that's what we're going to be working with. All right, and we're just going to go ahead and start with an example here. So example 1. Set up a little bit. Okay, so find volume. Volume formed by rotating region bounded by f of x equals 2 minus x squared, and g of x is equal to 1. And we're going to rotate that region around y equals -1. Okay, so we're going to follow the exact same process that we've been doing. You guys know this by heart now. Is we're going to do that 2D sketch. And if we can make an accurate 2D sketch, we've got it made, you guys. And then we're going to sketch that solid. Like, what's the solid going to look like? And we're going to do bounds if we need to, right? Bounds. And step 4 here is we're going to do our slice, and then finally we'll write the integral and solve it. Okay, so our sketch here, our sketch looks like this, right? So f of x is 2 minus x squared is this nice upside down parabola, right? Oh, that wasn't a very good sketch, but you guys get the right idea. So that's f of x. And then g of x is y equals 1. That's easy. So we're going to take this area and we're going to revolve it, not about the x-axis like we have done in the past, right? We're going to revolve it about this line, y equals -1. Okay. So if we're looking at this solid, it's going to have a hump, right? And that hump's going to be reflected. And then that's the outside of it, but the inside is going to be this flat, like a cylinder type there. So this is like kind of like an open football with the sides, you know, the ends cut off and then it's got a hole in it, maybe like one of those little muffs to stick your hands in, right, in the wintertime. Okay, so that's our solid sketch. Not very good, but there you have it. Okay, and then we're going to find our bounds. We need to find this point and this point, right? So bounds, we're going to set f of x equal to g of x. We want to find where those two functions intersect. So we'll do 2 minus x squared is equal to 1, and that means x squared is equal to 1, so x is equal to plus or minus 1, right? Okay, so we've got our bounds. And then our slice, if we took a slice of this thing, it would be our washer, right? Our washer here. There we go. You guys can see that. So we're going to draw our washer. Got our slice here. There we go. So it's going to have that little slice there, but it's going to have a big old hole. Right. Okay, and it's a vertical slice, so the thickness is dx. Little r in here is from this function up to the bottom of our slice, little r. So we're going to take this function, g of x, minus this function, which is -1. So we've got g of x is 1, g of x minus a -1, and I'm off the paper, sorry about that. So r is equal to 1 minus a -1, and you guys can see r is equal to 2. And that makes sense, right? As we travel across here from -1 to 1, this distance isn't changing at all. It's a constant 2. It's got 1 here and 1 here. Okay. Big R, though, that's what is definitely changing. So now we have to say, okay, big R, I'm going to write that down here. Big R is equal to the top function, which is f of x, minus the bottom function here, which is -1. Okay, so f of x is 2 minus x squared, and we're actually adding 1 because we're below the x-axis there. So we get 3 minus x squared is big R. Okay, so now we've got big R from this point all the way up. 3 minus x squared, little r is a constant 2. Okay, and now we're going to write our integral here. So step 5, I kind of have 5 steps today, integral. Okay, we're going to go from -1 to 1, pi, big R squared, 3 minus x, oh shoot, x squared, minus little r, which is 2 squared, times dx. Okay, and the way to do these, just FOIL out this 3 minus x squared squared. So, and I'm going to pull out the pi times. So this would be 3 squared is 9. And then our middle term is x squared times 3, and we're going to have 2 of those. So minus 6x squared, and then negative x squared times the negative x squared would be a positive x to the 4th. Okay, and then minus 4 dx, which is 2 squared. Okay, and we can kind of simplify this a little bit. Okay, so we've got negative 1 to 1 pi. 9 minus 4 is 5, minus 6x squared plus x to the 4th dx. Okay. And the last step is to antiderive. So the antiderivative of 5 is 5x. The antiderivative of 6x squared would be, let's see, 2x cubed. And the antiderivative of x to the 4th, x to the 5th over 5. And we're going to go from negative 1 to 1. And we can't forget that pi is still hanging out here because that is part of the answer. Okay, and then we're going to plug everything in here. So 5 times 1 minus 2 times 1 cubed plus 1/5. And then minus 5 times the negative 1 minus 2 times the negative 1 cubed plus a negative 1 to the 5th over 5. Okay, and then we just have some arithmetic to do. 5 minus 2 plus 1/5, and this is going to be a negative 5 minus a negative 5, which is plus another 5. And then this is a negative times a negative, which is positive, minus 2. And then a negative times a negative is a plus 1/5 again. So a little bit of work here. So we have 5 minus 2, 5 minus 2. So 3 plus 3 plus 2/5. So we have 6 and 2/5. Or we typically would write that, 32/5 pi. And that would be our answer. Okay. I think I'm going to stop it here, and I will do another example of dy slice coming up.